Dubro Suspicion Files.
Welcome to the Deep Dive. Today, we're tackling a fascinating story of scientific reversal. It's about how our picture of Mars completely flipped.
It really is quite the narrative. You go from this centuries-old idea of Mars with canals and maybe even intelligent life.
Right, the whole Percival Lowell fantasy, dying civilizations building waterways.
Exactly. And then the first actual missions arrive, Mariners 4, 6, and 7, and they just obliterate that idea.
They swung the pendulum hard the other way, didn't they? Suddenly Mars wasn't complex, it was just dead.
Yeah, the consensus became geologically inert, static. Basically a slightly more interesting moon, scarcely changed in billions of years.
So our mission today in this deep dive is to analyze the sources that pinpoint the exact moment that dead planet idea shattered.
And it centers on one specific mission, Mariner 9, arriving at Mars only to face this total crisis, a planet-wide dust storm, an absolute monster.
A storm that should have just shut the mission down, total visual blockade. But instead, 4 mysterious dark spots appeared through the haze.
Like little islands. And the big question we're exploring is how that single spacecraft, practically blinded, managed to reveal not just those spots, but that they were the key.
The key to Mars's biggest geological features.
Yeah.
The largest volcanoes, the largest canyon system in the entire solar system. It's incredible.
How did that happen? How did crisis turn into revelation? That's what we're digging into.
We're looking at the sources detailing Mariner 9, the science dogma it flew into, that environmental disaster, and the mind-blowing scale of those 4 features that literally rewrote planetary science.
Let's unpack how we got from canals to craters, and then from craters to the real Mars.
Okay, so to really feel the impact of what Mariner 9 found, we need to go back to that 19th century vision of Mars. It really gripped the public imagination.
It absolutely did. And it starts, interestingly, with an observation and a translation issue. Giovanni Schiaparelli, the Italian astronomer.
1877, right, during a close approach of Mars.
Yes. He meticulously mapped these linear features on the surface, and he used the Italian word canali.
Which just means channels or grooves, natural features.
Precisely. But when his work was translated into English, canali became canals, and that single word changed. It changed everything.
Suddenly, they weren't natural formations anymore. They were artificial waterways, built by Martians.
And that set the stage perfectly for Percival Lowell, an American astronomer, quite wealthy, built his own observatory in Arizona specifically to study Mars.
He really ran with the canal idea, didn't he?
Oh, completely. He became the chief proponent, the architect of this elaborate fantasy. He published these incredibly detailed maps showing hundreds of straight, intersecting lines crisscrossing the planet.
And his explanation was so vivid. A dying Martian civilization, he argued, desperately building this planet-wide irrigation system.
Yes. Ferrying water from the polar ice caps, which they could see were shrinking and growing seasonally, down to the equatorial regions where their cities supposedly were. It painted this picture of Mars as old, wise, perhaps melancholic, but definitely engineered.
And our sources stress this wasn't just, science fiction back then.
Not at all. For a good half-century, Lowell's hypothesis of intelligent Martians and their hydra engineering projects was considered a plausible hypothesis by many, including some in the scientific community. The maps seemed so detailed.
It seems like solid evidence at the time, but then came the space age, and reality hit hard.
It really did. July 1965. NASA's Mariner 4 spacecraft executes the first successful flyby of Mars.
And it sent back the first close-up pictures. Only about 34, I think. And grainy?
Grainy, yes, but revolutionary. They were expecting, perhaps, glimpses of canals, maybe cities. What they got was, completely different.
A desolate landscape, the report said.
That's the term used. The images, mostly of the southern hemisphere, showed craters upon craters and nothing else.
So the immediate reaction was, Mars is like the moon.
Essentially, yes. Primitive, battered by impacts, certainly lifeless, and crucially geologically inactive. The conclusion was stark. Mars had scarcely changed in 2 to 5 billion years.
What a swing, from a dying civilization to a dead rock.
And that view, the disappointing planet view, was really solidified just 4 years later. Mariners 6 and 7 flew by in 1969.
More images, confirming the craters.
Confirmed the craters showed absolutely no traces of the canals. By 1970, the scientific consensus, the absolute dogma, was that Mars was geologically inert, dead.
It's such a fascinating example of scientific overcorrection, as one source puts it.
Exactly. They were right to debunk Lowell's complex engineered Mars. That was based on misinterpretation and wishful thinking. But in doing so, they created an equally incorrect myth, the myth of a completely dead, unchanging planet.
They threw the geological baby out with the canal bathwater, so to speak.
You could say that. And the critical point here is that this dead planet dogma was built on a shaky foundation. It was based entirely on a sampling error.
A sampling error. How so?
Well, Mariners 4, 6, and 7 were flybys. They didn't orbit. They just zipped past. And purely by chance, their trajectories took them over the oldest, most heavily cratered parts of Mars, the Southern Highlands.
So they completely missed other areas that might have looked different.
They missed vast regions, including the areas that, as we now know, contain the most dramatic geological features. They basically judged the entire planet based on seeing its most ancient, battered terrain. It was a failure of, well, seeing the whole picture. #2. Mariner 9's high-stakes arrival in the Red Veil.
Okay, so that's the stage. A scientific community largely convinced Mars is dead. And into this steps the Mariner Mars 71 project. But it hit trouble before it even left Earth.
Huge trouble. The plan was smart redundancy. 2 identical spacecraft, Mariner 8 and Mariner 9.
It's designed to work together, right? One focusing on dynamic things like weather, the other doing a global map.
Exactly. Share the load, cover more ground, ensure success even if one had issues. A very sensible approach.
But then, May 9, 1971,
Disaster.
Mariner 8's launch vehicle, an Alice Centaur rocket, malfunctioned just minutes after liftoff. The upper stage started tumbling.
And the whole thing just plunged into the Atlantic Ocean, spacecraft and all, gone. Instantly, the scientific objectives of both missions landed squarely on the shoulders of the single surviving spacecraft, Mariner 9.
Talk about pressure. Suddenly, it wasn't a two-part mission. It was everything.
It became this incredibly high-stakes both-or-nothing gamble. Mariner 9 had to work. If it failed, America's Mars exploration plans would be set back years.
And this is all happening during the Cold War space race, too. There was external pressure.
Absolutely. The Soviets were also aiming for Mars in 1971 with their Mars 2 and Mars 3 probes. It was a frantic race to be the first to successfully orbit another planet and ideally land on it.
So Mariner 9 launches successfully just a few weeks later, May 30th, and heads towards Mars.
A 157-day journey. And NASA did score a major victory. On November 14, 1971, Mariner 9 successfully fired its retro rocket and slipped into orbit around Mars.
A huge achievement. The first human-made object ever to orbit another planet. They beat the Soviets.
A monumental moment, politically and scientifically. The team at JPL must have been ecstatic. But that celebration, it lasted about 5 minutes.
Because when they turned the cameras on to start mapping,
we saw nothing, or almost nothing. Just a fuzzy reddish-orange ball.
This was the immediate crisis. The entire planet was invisible.
It was engulfed, completely shrouded in one of the largest global dust storms ever recorded on Mars. An absolute behemoth of a storm, unprecedented.
And this wasn't just like a bit hazy. This was thick, opaque.
Incredibly thick. Our sources call it the Red Veil. The dust was so dense, so pervasive, that the surface was largely obscured. They measure this with something called optical depth.
Right, how much light gets through.
Yeah. And the optical depth was greater than 2 over most of the planet. An optical depth of 1 means you can barely make out the surface. An optical depth of 2, forget it, completely invisible.
So the first photographs beamed back were just featureless red.
Pretty much. Virtually nothing, as one account puts it. You can imagine the sinking feeling. You get your one spacecraft there, you win the race, you achieve orbit, and the planet just vanishes behind a curtain of dust.
The entire mission, all those scientific goals, were instantly jeopardized. What do you even do? So this total blackout, the planet's hidden, what were the options? Forge ahead and map the dust? Or wait?
That was the crucial decision, and it highlights a key difference between the American and Soviet approaches at the time.
The Soviets also arrived during the storm, right? Mars 2 and 3.
They did shortly after Mariner 9, but their mission plans were apparently quite rigid. Pre-programmed sequences they couldn't easily adapt or wait.
So what happened to them?
Well, unable to see where they were going or wait for the storm to clear, they proceeded with their landing attempts. Mars 2's lander crashed. Mars 3's lander made the first soft landing, transmitted for about 15 seconds, and then silence, likely victims of the intense storm conditions.
Wow. But the Mariner 9 team at JPL, they took a different path.
They did. They were more flexible. They had more advanced onboard computing, crucially, which allowed them to reprogram the mission sequence from Earth.
So they decided to wait it out.
Yes. They made the critical and ultimately historic decision to delay the primary mapping program. They essentially put Mariner 9 into a holding pattern, conserving its resources, and just waited.
For how long?
Through the rest of November 1971, all of December, right into early January 1972, weeks and weeks of patiently orbiting a featureless planet, hoping the storm would break.
That must have been agonizing. But you said earlier this waiting period turned out to be a blessing.
A profound scientific blessing in disguise. That's how the sources frame it. Because the dust storm, this catastrophe, inadvertently acted like a giant atmospheric filter.
A filter? How?
Think about it. The dust wasn't infinitely high. It filled the lower atmosphere, but the very highest points on the planet could potentially stick out above the main dust layer.
Like mountain peaks poking through clouds on Earth.
Exactly. The storm effectively filtered out all the low-lying and medium-altitude terrain, isolating only the planet's most extreme topography.
So while they waited, did anything become visible?
Yes. Two things, primarily. They could still make out the bright south polar cap, which was high and reflective, and, much more mysteriously, 4 persistent dark spots in the equatorial regions.
4 dark spots. Just 4. Against the bright dust cloud.
Just 4. Appearing as dark smudges against the brighter, hazy backdrop of the dust-filled atmosphere.
Now here's a thought from the sources. What if the sky had been clear when Mariner 9 arrived?
That's a fascinating counterfactual. If the sky had been clear, the cameras would have immediately started mapping, and the science team would have been flooded with data. Thousands of images showing plains, canyons, countless craters, channels, an overwhelming amount of detail.
And those 4 spots might have just gotten lost in the noise initially?
Very possibly. They might have been noted as interesting features, maybe unusual craters or plateaus, but their singular importance might not have registered for weeks or months amidst the sheer volume of other data.
But because of the storm?
Because of the storm, the only things the science team could focus on for almost 2 months were these 4 anomalous dark spots. Their significance was immediately elevated. The storm forced them to stare right at the planet's biggest secret.
So the storm did not hide the planet's greatest secret. It pointed directly to it.
That's the beautiful irony of it. The crisis became the instrument of discovery.
Okay, so the team is focused on these 4 dark spots emerging from the red haze. Which one did they really notice first?
The most prominent one, initially, was a feature already known from Earth-based observations, but known by a very different name, 𝐃𝐄𝐄𝐏.
𝐃𝐄𝐄𝐿, snows of Olympus. That sounds white and flat.
Exactly. That name reflects the old understanding. It was classified as a classical albedo feature.
Remind us what that means again.
An albedo feature is just a patch on the surface that looks brighter or darker than its surroundings when seen from a distance. It could be dust, frost, rock of a different color. But it implies contrast, not necessarily height. It's a 2-dimensional description based on telescopic views.
But Mariner 9 wasn't seeing a bright patch. Through the storm, it looked like a darkish spot.
Right. Dark against the surrounding bright haze. And that immediately suggested something different. Something tall enough to be poking above the main dust layer, showing its darker underlying rock surface.
So less like snow, more like a mountain peak.
That became the working hypothesis. Early radar data from Earth had also hinted that this region might be one of the highest points on Mars. So the thinking shifted. Maybe 𝐃𝐄𝐿 wasn't a flat patch of snow or frost, but a high mountain or plateau, seen as it rises up through the bright dust.
Okay, that makes sense for 𝐃𝐿. What about the other 3 spots? They were clustered together, right? In the Tharsis region.
Yes, in a distinct linear arrangement near the equator. And this is where that old dead planet dogma really clouded the initial interpretation.
How so? They saw dark spots poking through the dust too. Shouldn't they have thought mountains as well?
Logically, yes, but the bias was incredibly strong. The northernmost of these 3 spots, which had the temporary name Ascrieus Lecus.
Lucus, the lake. That implies low ground.
Exactly. The name itself was already based on old low-resolution maps suggesting a dark, possibly damp, low-lying area. And incredibly early descriptions from the Mariner 9 team, even while seeing it poke through the dust, didn't call it a mountain. They provisionally described it as a crater complex.
A crater complex? Poking above a global dust storm? How does that even work?
It shows the power of expectation. They were expecting to see craters because Mars was supposed to be moon-like. When the first, somewhat clearer, oblique images came through, they saw the circular shape at the summit.
The caldera we now know.
Yes, the caldera, but they interpreted it, according to the sources, as showing several intersecting shallow crater-like depressions. They even estimated one crater as being 21 kilometers across.
So they saw a giant volcanic caldera and called it a crater.
Essentially, yes. They acknowledged it must be a relatively high area to be visible, but their immediate interpretation framed it within the familiar dead planet context of impact craters, not active volcanic mountains.
Wow, that's profound cognitive dissonance, isn't it? The data is screaming mountain, but the brain is saying crater.
It really is. They were struggling to fit this completely new three-dimensional reality into their existing two-dimensional cratered world framework. The language itself failed them. Nix implying snow, lacus implying lake. These were terms from the old paradigm.
They were seeing features nearly 3 times the height of Mount Everest, but still defaulting to the language of a flat, dead world.
It took time and, crucially, better images as the dust cleared for them to overcome that ingrained bias and accept the revolutionary nature of what they were actually seeing.
So the JPL team's patience paid off. The dust storm finally starts to settle down. When did that happen?
It began to abate noticeably around January 2nd, 1972. Slowly, gradually, the red veil lifted.
And as the atmosphere cleared, the true nature of those 4 spots became undeniable.
Undeniable and absolutely spectacular. They weren't high-altitude craters, they weren't strange plateaus, they were definitively the central calderas of 4 enormous shield volcanoes.
This must have been the moment, the paradigm shift right there.
This was it. The dead planet idea died in early 1972. That isolated spot, Nix Olympica, was formally renamed. Its new name reflected its true nature, Olympus Mons, Mount Olympus.
And the scale of this thing,
Yeah.
it just defies earthly comparisons, doesn't it?
It really does. We need to give the listener a sense of this. Olympus Mons is, simply put, the largest known volcano in the entire solar system, period.
How big are we talking? Height first.
Okay. Its summit reaches 21.9 kilometers above the official Martian datum. That's 13.6 miles, or about 72,000 feet.
And the data on Mars isn't sea level, because there's no sea. It's based on average atmospheric pressure, right?
Correct. It's an artificial zero elevation point. But measured from that point, Olympus Mons is nearly 3 times the height of Mount Everest above sea level. If you measure it from the surrounding plains, it's about 26 kilometers or 16 miles high. Its peak literally pokes out above most of the thin Martian atmosphere.
Okay, that's vertical scale. What about its footprint? How wide is it?
Its base is about 600 kilometers across. That's 370 miles.
Put that on Earth for perspective.
Okay, if you plopped Olympus Mons down in the United States, its base would essentially cover the entire state of Arizona.
Wow.
Or if you put it in Europe, it would cover most of France. It's colossal. Its volume is estimated to be about 100 times the volume of Mauna Loa in Hawaii, which is Earth's largest active shield volcano by volume and mass.
Just one of these volcanoes, Olympus Mons, signaled a completely different Mars.
Completely. A Mars capable of geological processes on a scale far exceeding Earth's, at least for volcanism.
And what about the other 3 spots? The ones in a line in Tharsis?
They were confirmed as 3 more giant shield volcanoes, the Tharsis Montes, they're collectively called.
The one they thought was a crater complex, 𝐃𝐄𝐄𝐄𝐏.
That became 𝐃𝐈𝐕𝐄 Mons. It's the northernmost and tallest of the 3, reaching over 18 kilometers high, still vastly taller than anything on Earth.
And the other 2?
The middle one is Pavonis Mons, and the southern one is Arja Mons. Arja Mons is particularly wide, about 475 kilometers across its base, and stands nearly 12 kilometers high from base to peak. All 3 are classic shield volcanoes, broad, gentle slopes built up layer by layer from fluid lava flows.
So the unveiling wasn't just one giant volcano, but 4.
Yes.
3 of them in this massive chain.
Yes. And as Harold Mazursky, one of the Mariner 9 team leaders, stated definitively at the time, the revelation of volcanoes on Mars thus overturned the Mariner 4, 6, and 7 thesis that Mars was a dead planet. It was undeniable proof of a dynamic interior.
Okay, so they found these 4 monster volcanoes. The next obvious question is, why? Why are they so incredibly huge, way bigger than anything on Earth?
And the answer to why they are so big turned out to be just as revolutionary as the discovery itself. It revealed the fundamental difference in how Martian geology works compared to Earth's.
It comes down to plate tectonics, or rather the lack of them on Mars.
Exactly. That was the crucial insight derived from their sheer scale. On Earth, as you know, the outer shell, the lithosphere, is broken into tectonic plates that move around.
Right, they drift over the hotter mantle beneath.
Precisely. So if you have a stationary plume of hot magma rising from deep within the mantle, a hot spot, the plate above it, keeps moving.
Like the Hawaiian Islands, the Pacific plate moves over the hot spot, creating a chain of volcanoes.
Perfect example. The hot spot stays put, the plate moves, and you get a series of volcanoes that are born, grow, move off the hot spot, and die, becoming extinct. No single volcano stays over the heat source long enough to grow truly enormous by Martian standards.
But on Mars, the crust doesn't move like that.
It appears not. The evidence from Mariner 9 and subsequent missions strongly indicates that Mars has, or had, a largely static lithosphere. A one-plate planet, essentially. The crust doesn't drift horizontally over mantle plumes.
Ah, so if you have a hot spot under that static crust.
The magma just keeps erupting in the exact same spot for millions, maybe hundreds of millions, possibly even billions of years in the case of Olympus Mons. Layer upon layer upon layer of lava builds up, creating one single colossal shield volcano instead of a chain of smaller ones.
So the size of Olympus Mons and the Tharsis Montes isn't just impressive, it's direct evidence against Earth-style plate tectonics on Mars.
It's probably the most dramatic piece of evidence. Their scale is a direct consequence of the planet's static crust.
And these volcanoes, they aren't just sitting on flat ground, are they? They're part of an even bigger structure.
That's right. They sit atop the Tharsis Bulge, or Tharsis Rise. This is a vast volcanic plateau, thousands of kilometers across. That itself swells upwards, rising nearly 10 kilometers. That's about 33,000 feet above the average Martian elevation. It's like a huge blister on the planet's surface.
So you have this immense bulge, and then these 4 monster volcanoes piled on top of it. That's an incredible concentration of mass in one region.
Astonishing, as one source calls it. We're talking about a continent-sized load pressing down on the Martian crust.
What does that kind of weight do to a planet's surface?
It causes immense stress. The sheer weight of the Tharsis Bulge and its volcanoes was too much for the Martian lithosphere to support uniformly. It caused the crust to sag beneath the load and also to stretch and crack around the edges.
Stretch and crack. Leading
directly to the formation of Valles Marineris, the largest canyon system in the solar system.
Wait, the volcanoes caused the canyon. How are they connected?
Valles Marineris isn't a canyon carved by water like the Grand Canyon. It's primarily a massive tectonic rift system, a series of enormous cracks or graben formed by the crust being pulled apart. And it's located right on the eastern flank of the Tharsis Bulge.
So the bulge swelled up, the immense weight caused the crust nearby to stretch and fracture.
Exactly. The strain ripped the crust apart, forming this gigantic system of interconnected troughs and canyons. Valles Marineris stretches for 4,000 kilometers, about the width of the continental U.S., and plunges up to 10 kilometers deep in places. It's the tectonic scar resulting from the formation of Tharsis.
That's incredible. So discovering the 4 spots wasn't just finding volcanoes, it was finding the engine driving Mars's largest scale tectonics. Volcanoes and the giant canyon are part of the same system.
It connected the dots. The Tharsis Bulge, the 4 giant volcanoes on top of it, and the Valles Marineris rift system on its flank, they are all manifestations of this one massive Martian geological engine centered on mantle upwelling and volcanism under a static lid.
And once they understood this volcanic engine was real, it opened up other possibilities, didn't it? Like water.
Absolutely. Because massive, prolonged volcanism doesn't just produce lava. It releases enormous quantities of gases and water vapor from the planet's interior, a process called outgassing.
So the heat and activity from Tharsis could have pumped huge amounts of water into the early Martian atmosphere and onto the surface.
That became the leading hypothesis. And with this new framework, a geologically active Mars with massive volcanoes, the scientists could look again at the Mariner 9 images, all 7,329 of them eventually.
And what did they find now that the dead planet filter was off?
They found unmistakable evidence supporting that idea. Features that looked exactly like dried up river runoff channels, vast outflow channels apparently carved by catastrophic floods, intricate networks of carved gullies on crater walls, features strongly suggesting that liquid water once flowed on Mars, perhaps in vast quantities, and potentially enabled by the heat and volatiles released by the Tharsis volcanic system.
So the 4 dark spots were the key that unlocked not just volcanism and tectonics, but also the evidence for ancient water on Mars.
They were the first crucial domino. They forced the paradigm shift that allowed all the other pieces of modern Mars understanding to fall into place.
Okay, so the 4 spots were a real anomaly. real data that forced science to completely change its model of Mars. But Mars seems to attract other kinds of anomalies too, right? Things that look weird but aren't what they seem.
Oh, definitely. Mars has been a prime target for pareidolia, that human tendency to see familiar patterns, especially faces, in random or ambiguous stimuli, like seeing shapes in clouds.
And the most famous example of this on Mars has to be the face on Mars.
Absolutely. It's the classic counterpoint to the discovery of the volcanoes. A perfect example of a false anomaly, an illusion, versus the true anomaly of the Tharsis Montes.
Where did the face story start? It wasn't Mariner 9, was it?
No, it came later, July 1976. NASA's Viking 1 orbiter was imaging the surface, scouting for potential landing sites for the Viking lander in a region called Cydonia.
And it snapped a picture of a hill, a mesa, that looked uncannily like a human face.
Uncannily, staring straight up from the Martian plains. It had what looked like eyes, a nose, a mouth, even sort of a hairline or headdress. The picture caused an immediate sensation when it was released.
Fueling all sorts of speculation about ancient Martian civilizations, monuments.
Exactly. It became a staple of fringe theories and tabloid headlines for decades. But the scientific explanation was far more mundane, though interesting in its own right. It was basically a trick of light and low resolution.
How did those factors create the illusion?
Several things combined. First, the original Viking image resolution was quite poor by today's standards. The feature itself is large, about a mile across, but the image didn't have enough detail to show its true geological nature clearly.
Okay, low resolution.
Yes, lighting was critical. The photo was taken when the sun was very low in the Martian sky. The sun angle was approximately 20 degrees, according to analyses.
Like sunrise or sunset lighting?
Precisely. And just like on Earth, low sun angles create long, dramatic shadows. These specific shadows fell across the mesa in just the right way to fill in certain areas and highlight others, mimicking the contours of a face, creating the illusion of eye sockets, a nose bridge, a mouth.
So change the lighting, change the face.
Pretty much.
Yeah.
And there was a third factor, too, data artifacts. The raw image data wasn't perfect. There were transmission dropouts, bit errors that showed up as black dots on the image.
And those dots influenced the perception.
Yes, sources confirm that some of these random black dots comprise part of one of the eyes and nostrils. So it was a combination of a naturally eroded hill, specific shadows, low resolution, and data noise, all working together to create this compelling illusion.
So how did science eventually resolve this? The same way it tackled the 4 spots, I assume. Better data?
Exactly the same process. Skepticism, patience, and demanding higher resolution verifiable evidence. The scientific method requires testing hypotheses with better observations.
Which missions provided that better data?
Primarily the Mars Global Surveyor, MGS, starting in 1998, and later the Mars Reconnaissance Orbiter, MRO, from 2007 onwards. These spacecraft had much more powerful cameras.
What did their images show?
MGS got images with about 10 times higher resolution than Viking. MRO's high-rise camera provided remarkably detailed images, showing features just a meter or so across. And crucially, they imaged Cydonia under different lighting conditions, including when the sun was high in the sky.
And the result?
The illusion vanished completely. When you see the high-resolution images under normal lighting, it's clearly just a natural geological formation, a mera, a remnant of eroded bedrock common in that region of Mars. It has bumps and ridges, but absolutely no symmetry, no carved features, nothing resembling a face.
So it's a fascinating contrast. The 4 spots versus the face.
It really is. It highlights how science works. The 4 spots were a true anomaly, real data, giant mountains, that contradicted the existing model, dead planet, and forced a scientific revolution.
While the face was a false anomaly, an illusion created by poor data quality, specific lighting, and our own psychology. It didn't require a revolution, just correction with better data.
Right, and in both cases, the path forward was the same. Don't jump to conclusions, be skeptical of initial interpretations, and insist on more and better evidence. That process eventually revealed both the real volcanoes and the illusory face for what they were. Hashtag tech tag outro.
So we started this deep dive looking back at a Mars shrouded in disappointment. A planet deemed inert, moon-like, a scientific dead end after the initial flybys.
A consensus built on incomplete data, an overcorrection from the earlier fantasies.
But then came Mariner 9, arriving in the midst of that catastrophic global dust storm, the Red Veil. A situation that looked like mission failure.
Yet through the ingenuity and, crucially, the patience of the JPL science and engineering teams, that veil wasn't a barrier. It became an instrument, a filter.
A filter that isolated 4 dark spots, forcing humanity to recognize the true giants of Mars. Olympus Mons, Tharsis Montes, Valles Mons, and 𝐃𝐈𝐕𝐄 Mons.
These weren't just big mountains. Their discovery completely shattered the dead planet paradigm. They revealed Mars as a world with a dynamic interior capable of volcanism on an unbelievable scale.
And understanding that volcanic engine, driven by the massive Tharsis bulge under a static crust, unlocked everything else. It explained the Valles Marineris, the solar system's largest canyon, as a direct tectonic consequence.
And it provided the framework for understanding the abundant evidence Mariner 9 also found for ancient rivers, floods, and gullies linking Mars's internal heat and outgassing to a past when liquid water flowed freely on its surface.
It's really no exaggeration to say that Mariner 9 and the discovery forced by that dust storm laid the entire foundation for modern Mars exploration.
Absolutely. It transformed Mars from a disappointing planet into arguably the most interesting planet in the solar system besides Earth, a far more complex world, a world unto itself.
The revelation of dynamism, of past water, made Mars the prime target for the search for past, or maybe even present, habitability. It set the stage for the Viking landers just a few years later, for Mars Global Surveyor, Pathfinder, and all the rovers, Spirit, Opportunity, Curiosity, Perseverance that followed.
They are all, in a very real sense, the scientific descendants of Mariner 9 and its encounter with the Red Veil. That moment in 1971-72 defined the questions we're still trying to answer about Mars today.
So we'll leave you, our listeners, with a final thought to consider building on this incredible story.
Think about this. We've established that the Tharsis Bulge, with its colossal volcanoes, was this immense geological engine. It stretched the planet's crust, created Valles Marineris, and likely drove massive releases of water and heat to the surface billions of years ago. If that much geological energy was present,
Could that same engine have created conditions suitable for life?
and perhaps more intriguingly, given the immense scale and longevity of these volcanoes, could the geothermal heat still lingering deep beneath them, combined with potential subsurface water locked away from the harsh surface, could those environments, protected beneath those giant mountains, still harbor secrets? Maybe even relating to the persistence of simple life.
It turns out those 4 dark spots, first seen as islands in a dust sea, might still be guarding the deepest mysteries Mars holds.